So what we're doing here is we're trying to understand how I think it's called superposition, or interference anyway. You can get different waves to interfere and make a more complex wave like this. And we're going to try to understand how it works by doing it manually. So we've got two graphs here. One has got half the wavelength of the other. What we're going to do is we're going to look at the displacement each time. So let's imagine that is 1 and that is 2. So that would be 0 and that would be -1 and that would be -2. So again here that would be 0, 1. I don't need to do the rest of that actually. -1 and 0, and this time we are going to do all of it because we're going to be adding these. So -1 and -2. So what we do is we look at the first, we're going to go for every small square for the moment. So we're going to go, what is it here, 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 well, not small square, but like that. And we're going to just join them up. And we could always, if we're not sure what the pattern is, we could always go halfway as well. So at the beginning, the displacement for both of them is 1. I'm going to use a different color here. So I will use like a pink. So the first plot is, we know that the graph is going to go through there. The next one, we've got 1, but we're going to add to what we've got here, which is somewhere up there. It's about 0.7, something like that. So therefore the sum is going to be 1 plus 0.7, which is 2.7. So it's going to go up to about here. And next we've got, for the next one, we've got 0.5, and it's 0.5 plus 1. So that's going to be 1.5. So that's going to be there. Then the next one we have is hang on a second. Oh, hang on, I've done something wrong here. Yes, I've done that wrong. So it was 1 plus, not 0.5, plus 0. Okay, because on the second line, this one here, it would help because if I'm making a mistake and it's going to be hard enough to follow, I will get a little line like this, and this can be our kind of marker line, so as we can keep track of where it is that we're drawing the lines. So we're doing it on this point here, and we have a 1 there, and we have a 0 here, so the answer is 1. Now to the next halfway point, which is over here, and we have -1 and positive 0.7, which means that's going to give us negative 0.3-ish, just around about there. So you can see how this is going. It's making a reasonably strange graph. It's going up there, then down like this. I'm going to keep going, and I'll get you to do a few more yourself. So now we've got a 0 here, and also a 0 there. So that goes like that. And then we've got to go to this one. We've got a 1 here and a negative 0.7 there. So we end up with about 0.3. Oops, my pen. Okay, so I'm going to stop there and then let's see you have a go at it. Okay, so we plotted them all. We continued to plot them all. We got to around about here, and we realised we can probably predict what the rest of them are, just because we've started to notice how the pattern is repeating itself here. Now, this doesn't look much like a wave at the moment. It's difficult to really work out what it's going to do. What you would do if you were doing pen and paper is you would use just basically join dot to dot like this and try to produce It's a smooth sort of curve. But we're going to do it with the line tool here. So I'm just going to start doing it on the video. I don't want it to be a dotted line though. I want it to be a smooth line. So let's turn that into solid. And let's make it blue, sure. So I'll make the anchor point up here. Like that. And then we're going to drag this one down to there. Whoops. And make an anchor point up there. Then we're going to drag that one there. And drag the anchor point down to here. And keep repeating this. I won't do all this on video. I'm just going to get the beginning one done. Okay. Right, so we start to see a pattern starting to emerge now. Starting to look a bit more like a wave, but like a complex wave. A combination of the two waves. I'm just going to make it all the way up to here this time. Okay, I'll just pause the video. I'll see if you can continue with that. Okay, so we've ended up with this pattern here, and let's see if we can try to understand why it is this pattern, or like try to. I guess we understand why because we just made it, but can we try to make sense of it a bit more? If we go to this point here, at that point we've got one big hump at the top and a hump and a crest and a trough at that one there. So that's kind of like that's like half the wavelength of the first one, but a full wavelength of the second one. Once you go to this bit here, we have a full wavelength of the first one and two full wavelengths of the second one. So that means this is going to be the new wavelength of our complex wave, because by this point we're now back to the beginning and we're starting to repeat the process. So we're adding the crest to the half the crest of that to the crest of this one, then the second half of the crest of that to the trough of this one, and so on and so forth. So hopefully you can see that it would make sense that it's going to repeat every time it gets to this. Now you can play around with this and you can start to see, well, what would I get? Like if we look at this one here, we can see the pattern repeats every time we get to one of these. You can even add like more than one wave. You could add more than two waves. You could add like a really short wavelength and then like two fairly similar longer wavelengths and see how that would work. Essentially, as you can see here, we've got a much more high frequency one on top of a low frequency one. And it's like the low frequency wave we call it the carrier of the high frequency wave. So it's got information inside information here. Anyway, this gives us a glimpse of how wave packets work in quantum physics. If you remember when we were looking at quantum physics, we had not just two waves, but actually, I don't know what they said, like thousands or millions of waves on top of each other. So as it closes it together and makes it a kind of what they call a wave packet. So this is just going to give us more of a kind of understanding of how that works. Okay.